Good morning, students. Chapter 6, Work, Energy, Power. Yes, it's last lecture for work, energy and power. Yes, we know what is collision, and yes, there are different types of collision. We have discussed about elastic collision. What is elastic collision, or we can say perfectly elastic collision? What is elastic collision? So yes, if kinetic energy after collision, if kinetic energy after collision is equal to kinetic energy before collision. It is called elastic collision. Yes, you know about elastic collision. Okay, and yes, we have defined one constant that is called coefficient of restitution. That is E is equal to. What is E is equal to? Yes, it is relative velocity after collision divided by relative velocity before collision. Okay, coefficient of restitution is equal to relative velocity after collision is equal to relative velocity before collision. And if you remember, we have proved for elastic collision that u1 plus v1 is equal to u2 plus v2, or you can say u1 minus u2 is equal to v2 minus v1. It is relative velocity after collision, it is relative velocity before collision. So yes, they are same. So yes, coefficient of restitution for elastic collision E is equal to 1. For elastic collision E is equal to 1. That you have to remember. Clear about this? Yes. Coefficient of restitution for elastic collision E is equal to 1. Okay. Now, another type of collision. It is elastic collision. What is inelastic collision? Inelastic collision. So yes, difference is simple. If kinetic energy after collision is equal to kinetic energy before collision, then it is elastic collision. But if kinetic energy is not same, then obviously it is called inelastic collision. Okay, if kinetic energy after collision is not equal to kinetic energy before collision, it is called inelastic collision. Clear about this? Yes, in elastic collision, kinetic energy is conserved. So what is change in kinetic energy? Yes, change in kinetic energy is 0. But in this case, as kinetic energy before and after is not same, so here kinetic energy is not 0. Here change in kinetic energy is not 0. Plus, here relative velocity after collision is equal to relative velocity before collision. So coefficient of restitution is 1. But here coefficient of restitution is not 1. Here that coefficient of restitution is between 0 and 1. So yes, this point you have to remember. Okay, and yes, you can find this value of E from that any given case, Okay, Last one and third one is third type of collision, that is called perfectly inelastic collision. Perfectly inelastic collision. What is perfectly inelastic collision? Okay, we have discussed some questions. If it is block of mass m, it is bullet of mass m, it is moving with speed u. Okay, then after collision, they both move with same velocity. So after, if two bodies stick together after collision, if two bodies stick together, or they move with same velocity, it is called perfectly inelastic collision. It is called perfectly inelastic collision. Clear about this? So it is example of perfectly inelastic collision. And see, as these two objects are moving with same velocity, what is relative velocity after collision? 0. So relative velocity after collision is 0. So coefficient of restitution E is equal to, it is 0. Coefficient of restitution E is equal to, it is 0. Clear about this? So yes, you have to remember 3 cases of collision. First, elastic collision, then inelastic collision, and third one is perfectly inelastic collision. And yes, we have observed some questions based on perfectly inelastic collision. Okay, after collision, two objects stick together and move with same velocity. Clear about this? Okay, so yes, these 3 cases you have to remember. Now we will see some questions. See, here it is. A body of mass 0.5 kg travels. A body of mass 0.5 kg travels in a straight line with velocity v is equal to a x raised to 3 by 2, where a is equal to 5 meter raised to 1 by 2, second raised to minus 1. What is the work done by net force during its displacement from x is equal to 0 to x is equal to 2? Okay, see how to find this question. A body of mass 0.5 kg. So yes, m is equal to 0.5 kg. Travels in a straight line with a velocity. Here it is. V is equal to a x raised to 3 by 2. Yes, it is x raised to 3 by 2. And where what is value of a? It is 5. So I can write here v is equal to, it is 5 x raised to 3 by 2. Clear about this? Okay. What is work done by net force during its displacement from x is equal to 0 to x is equal to 2? See, you are not given any force. So how to find work done? Yes, we can use this example. See, that is work energy theorem. Okay, what is work energy theorem? It is W is equal to delta K. That is W is equal to change in kinetic energy. That is K2 minus K1. Okay, so W is equal to half m v2 square minus half m v1 square. So is equal to half m v2 square minus v1 square. Half, just you know, m you are given, you have to find v2 and v1. Now what is v2 and v1? See, you have to find work done by net force during its displacement from x is equal to 0 to x is equal to 1. So obviously, when x is equal to 0, v is equal to v1. Yes or no? X is equal to 0 means it is initial velocity. Then how to find that initial velocity? You have to put v1 v1 is equal to 5. What is value of x? It is 0. What is value of x? It is 0. So v1 is equal to 0. Simple. Okay, because it is starting from x is equal to 0. So at x is equal to 0, you have to write v is equal to v1. So v1 is equal to 5, 0 raised to 3 by 20 is 0. Now, when x is equal to 2, v is equal to v2. Then how to find v2? v2 is equal to 5. Yes, x you have to replace by 2. So it is 2 raised to 3 by 2. It is 2 raised to 3 by 2. So is equal to, it is 5. It is 5. Okay, first of all, 2 raised to 1 by 2. 2 raised to 1 by 2, or it is 2 cube. 2 cube, so it becomes 8. 8 raised to 1 by 2. Now 8 raised to 1 by 2 means 8 means 4 into 2. 8 means 4 into 2. 4 into 2 raised to 1 by 2. So it is equal to 5. 4 raised to 1 by 2. So it is 2. And this 2 raised to 1 by 2 means it is root 2. So it is 10. It is 10. Clear about this? Clear about this? So yes, v2 how to find? Any doubt? You are given equation of velocity. Yes, you are given equation of velocity. Velocity is function of x. First of all, you have to find velocity when x is equal to 0, v1. Then you have to find velocity when x is equal to 2, v2. Now put value in this equation. That is how. So what is value of m? M mass is 0.5. It is 0.5. v2 square. v2 square means this. 10 root 2 square minus v1 square. So that is 0 square. Okay. So is equal to, it is half into 0.5 into 10 root 2 square. 10 square, it is 100. And root 2 square, what is root 2 square? Yes, it is 2. Yes, it is. Clear about this? Clear about this? So yes, it is 2 cut. It is 2 cut. And now 0.5 into 100. 0.5 into 100. So it is 50. So it is 50. Clear about this? 0.5 into 100 means it is 50. So it is how to find, work done by net force during its displacement from x is equal to 0 to x is equal to 2 meter. Which equation you have to use? W is equal to delta K. W is equal to delta K. Clear about this? So yes, again it is one easy question. We will see some questions. Now next question, see what is next question. Two identical ball bearings in contact with each other and resting on a frictionless table are hit head on by another ball bearing of same mass moving initially with speed v. If collision is elastic, which of the following is possible? See what is question, here it is. Two identical ball bearings in contact with each other and resting on a frictionless table. Means this 2 and 3, these are two ball bearings. Okay, are hit by another ball bearing of same mass. It is another ball bearing of same mass. Okay, yes, moving initially with speed v. It is moving initially with speed v. If collision is elastic, which of the following cases? Which of the following cases possible? See what is question. Here it is. Two balls in contact with each other. They are resting, means that velocity is 0. Okay. One ball having same mass moving with velocity v collides with these two ball bearings. Okay. Then after collision, this situation is before collision. This situation is after collision. Your question is, if collision is elastic, then which case is possible? A, B or C? Okay, we know that when collision is elastic, okay, for elastic collision, kinetic energy before and after collision is same. So yes, here I will find what is total initial kinetic energy before collision and then after collision. See, in each and every case, before collision, you are given only one system. So first of all, I will find what is total initial kinetic energy or kinetic energy before collision. So kinetic energy before collision. So it is Ki is equal to, yes, you are given these ball bearings of same mass. So I am assuming let mass of each and every ball is m. Mass of each and every ball is m. Okay, let mass of each ball is m. Let mass of each ball is m. Okay, so see, Ki is equal to, this first ball is moving with velocity v. So what is its kinetic energy? It is half mv square. Plus these two balls, they are in contact. So it is half 2m. Why 2m? Because they are in contact. They are stick together. Half. And what is their speed? So it is 0. Here it is 0 square. So what is total initial? What is total initial kinetic energy before collision? It is half mv square. Equation number 1. Clear? Now what you have done? In this option A, after collision, find total kinetic energy. If this kinetic energy is equal to half mv square, elastic is collision. If it is not equal to half mv square, collision is not elastic. Then find similar thing for B, find for C. Okay, see how to find. First of all for A. Chalo. We will find kinetic energy after collision. Okay, so how to find? Kf is equal to half, only one sphere having mass m, but its speed is 0, so it is 0 square, plus half. These two, they are moving together with speed 2m, and having, these two are moving together, so their mass is 2m, with speed v by 2, so it is v by 2 whole square. Okay, now we have to simplify this. It is 0 plus 2 cut, and it is half m v square, it is m, here it is m v square by 4, means it is mv square by 4. But what is initial kinetic energy? It is half mv square. It is half mv square, and here it is mv square by 4. So it is not elastic collision. It is not elastic collision. Clear about this? It is not elastic collision. Now you have to find for option B. Chalo, for option B, that is here. Okay, what is final kinetic energy? Kf is equal to 1 and 2, they are moving together, so it is half 2m, that speed is 0 square, plus this third ball is moving, having mass m with speed v, so it is half mv square, so it is equal to, it is 0 plus half mv square, and see, this kinetic energy is equal to kinetic energy before collision. This kinetic energy is equal to kinetic energy before collision. So yes, it is elastic collision. It is elastic collision. Now for question number C. Yes, these three balls, they are moving together with common speed v by 3. So yes, you have to find what is their final kinetic energy. And you have to check if there is elastic collision or not. Okay, so yes, you have to find kinetic energy. You have to find kinetic energy after collision. Write equation of kinetic energy in comment. Also you have to write if this collision is elastic or not. Clear about this? So yes, answer of question number C you have to write in comment box. Okay, now we will see one another question. Last question for today. See what is question. A spring is compressed. See, a spring is compressed by 1 centimeter by a force of 3.92 Newton. Find the potential energy of spring when it is compressed by 10 centimeter. See how to find. How to find. What is given? A spring is compressed by 1 centimeter. X1 is equal to 1 centimeter. 1 centimeter 1 into 10 raised to minus 2 meter. By a force, F is equal to 3.92 Newton. Okay. Find the potential energy. U is equal to what? When it is compressed by 10 centimeter. X2 is equal to 10 centimeter is equal to 10 into 10 raised to minus 2 meter. Okay. Or you can say it is 10 raised to minus 1 meter. What is equation of potential energy? Yes, U is equal to, it is half K x square. But for displacement, 10 centimeter you have to find. So here I have to write x2. x2 you are given 10 raised to minus 1. But you do not know value of K. Then how to find value of K? With the help of this data. We know that F is equal to Kx. Here I will write x1. Minus sign, negative sign is neglected. Okay, yes. So how to find K? K is equal to F upon x1. K is equal to, it is F upon x1. What is value of F? It is 3.9 divided by x1. 1 into 10 raised to minus 2. So it is 392 Newton per meter. Clear about this? Okay, so it is how to find spring constant with the help of force and displacement. Now put value in this equation, that is U is equal to half. What is value of K? 392. What is value of x2? It is 10 raised to minus 1 whole square. Whatever answer, okay, you have to write in comment box. Yes, you have to write this answer in comment box. Clear about this? So yes, it is one question which is based on potential energy stored in spring. Potential energy stored in spring. Clear about this? So yes, students, with this, yes, this chapter number 6, that is work, energy and power, is over. And with this sum for today, this is it.